Hello, geometers and general seekers of truth. Welcome to the example of how to bisect a line segment and, more importantly, prove why it works. So, because in this class we've done bisecting a line segment many times before, I'm going to go through that part a little bit quicker and focus more of the time and energy here on the proof of why it works. Because many times we do this, we just kind of say that it works, but we never actually demonstrate or explain or give any sort of reasonable argument as to why it works. So here we go. First, put the needle on A and extend the pencil past the halfway mark. So we don't have to know exactly where it is, but we need to go for sure past the halfway mark. I'm going to draw one big arc right there, one arc, part of it that extends over the top of it, and part of the arc that goes down below it. All right. Now, keeping the compass the exact same size, flip it around, put the needle on B, and essentially do the exact same thing. Draw an arc there, and oops, man, I gotta get better at drawing my arcs. There we go. And we want the arc to be big enough such that part of it is above the line and part of it is below the line. I'm slipping a little bit here, so let me do this carefully. There we go. Much better. And if you notice, the two arcs will intersect each other twice. Once above the line, so we'll call this point here C, and once below the line, so we'll call this point here D. Okay? So again, I'm going through this a little bit quick, but you need to be able to understand how this works, and you should also list your steps. If you forget how to do this, look at one of the older videos or older lessons on how to bisect the line segment. And then I'm going to connect CD. The intersection of CD and AB is M. Okay, so my claim here is that M is the midpoint of AB. Now, whenever we make this sort of claim, we need to prove it. Okay. So what we need to show is that AM and BM are exactly the same size. So we need to show that AM is precisely congruent to BM. Right. It's so tempting just to say, yeah, obviously it is. It looks like it, but the word obviously should not belong in the discussion when we talk about proofs. Right? Nothing is obvious until, of course, after we've proven it. So to prove this, we're going to use congruent triangles, just like we did before. And I'm going to start by making these blue line segments here. Now, this part isn't quite obvious, but it's almost obvious that those blue line segments have to be congruent. Why? Well, because we made it that way. We constructed them. We did not change the size of the compass. You see? So when we first drew in those arcs, because we kept the size of the compass the same, we can be sure that all four of these line segments are exactly congruent to each other. I'm just going to make this a little bigger. That's point A, that's point B, that's C and D. Now, many times in geometry, in order to solve a problem or to complete a proof, it's a matter of perspective. And I want to turn your attention to this. Maybe I can do this a little bit better. So I want to turn your attention to a couple of triangles here, namely triangle, this one right here. All right, this is triangle DCB, and this triangle over here, DCA. Okay, and pardon my freehand drawing here. It's not as smooth as I would like. I can't quite use a straight edge of ruler right here. But those two triangles, okay, if you look at them, we can see that BC and AC are congruent. DB and AB are congruent. I'm just reiterating the marks. And then this line here in the middle, DC, is congruent with itself. So the big triangle on the left and the big triangle on the right must be congruent with each other. So I've written up that little proof right here. Basically, I'm writing that AC and BC are the same, AD and BD are the same, DC and CD are the same up and down the middle, and so the two triangles, the one over here, the big yellow one on the right and the big yellow one on the left, have to be congruent by side, side, side. Now, because they are congruent, all right, we can say something even more powerful. We can say that the corresponding parts of them must be congruent. Namely, this angle up here and this angle over here. Okay. So angle ACM is congruent to angle BCM by CPCTC. Right. Now I'm going to clean up this picture so that we can move on to the final part of the proof here. So from what we had before, now we know that this angle here and the angle to its left, okay, ACM and BCM, are congruent with each other. Now I ask you to turn your attention to a different triangle this time. Let's take a look at these two smaller triangles. Okay, the two green ones that I have right there. Well, you see that they have a common side, this one and this one, AC and BC. They have the common angles that we just proved were congruent, BCM and ACM. And then they actually have a reflexive side right here in the middle that's congruent to itself. So I'm going to quickly write up that proof. All right, and I don't have to say too much because I've already said AC is congruent to BC above, so that actually gives me a side. ACM is congruent to BCM, so this gives me an angle. And now I have CM is congruent to MC, and this is the reflexive property. So that's enough for me to say that the two green triangles are in fact congruent with each other. So I can finish this by saying triangles ACM is congruent to triangle BCM by the side angle side postulate. Okay, sorry, I'm writing a little bit off the screen here. Let me adjust this. Okay. ACM and BCM are congruent. And finally, I can finish the proof. Because the two triangles are congruent, then AM and BM must also be congruent. By corresponding parts of congruent triangles are congruent. So there you have it. I've shown you this in a lot of detail, a lot of steps, but the main idea for you to take away is first we had the two big triangles that we showed were congruent, so we get the little angles in here, and then that helps us prove that the two green triangles are congruent as well. As always, ask for help if you need it. This is a difficult, lengthy proof, but you can definitely do it. Just practice and study hard. Thank you for watching, and have a wonderful day.